Okay, at the end of the last video, we were talking about Hooke's law, which is F equals kx, and we were talking about elastic potential energy, the energy stored in something that's stretched or compressed. And for us, for the most part, that will be a spring or an elastic band, a rubber band. Okay? If you think about the force here, like if we think about what's the force that we need to stretch this spring some distance. So we'll call this point here X, and this point here, pen's still dying, F. Okay? And so if we think about the work done to stretch it, W equals F delta D cos theta, and the cos theta will be 0 again. But remember when we use this W equals F delta D cos theta, the F has to be the average force. So the average force here would be, down here it would be 0, so it would be 0 plus F over 2. And the distance, the delta D, would be your X. Okay, and cos theta would just be 1. So really this would be 1/2, pull that out front, 0 plus F, but F is really kx from Hooke's law. And so we get W is equal to, the first term will be 0. That's going to be your initial, like the initial, so it'll be 1/2 kx squared. And this is what the elastic potential energy is. Oh yeah, I didn't write that up here. Elastic potential energy is EE. Okay, where just like for the gravitational, the initial term will be 0. Okay, so the elastic potential energy is 1/2 kx squared. Sometimes you might have to use F equals kx to get the k to fill it in here. Okay, so that's elastic potential energy. You will have a few questions with it this evening. One last other piece before we get into putting it all together. And that one last other piece is something called efficiency. How efficient something is simply means how well something uses an object, an instrument, an apparatus, uses the work or energy that's put into it, how well it converts it into useful work or energy. So how well an object uses work / energy, because remember, one's kind of the same as the other. Work it results in a change in energy. How well an object uses work / energy put into it to convert it to useful work / energy. Okay, so what I mean is, like, let's think about the microwave. You plug the microwave into the wall, so it's using electrical energy, and it's turning that electrical energy into heat energy to cook your food. If it was 100% efficient, then all the electrical energy would be converted into heat energy, but we know that isn't true. Okay, so when we talk about the efficiency of an appliance, it's like how well does it take the electrical energy and turn it into the energy that you're using. Really, we often talk about how efficient our digestive system is or our metabolism is. How well does our body break down the food we eat and turn it into useful energy or work for us. Okay, a laser is one of the worst efficient devices. When lasers were first built, they were about 1% efficient. I think they're about 5% right now. Anything that gives off heat when you're using it, like a light bulb, is not going to be very efficient because some of the energy put into it is being converted into a different type of energy that is not what the appliance or the apparatus was for. In real life, hardly, in real life, if you get anything above 80%, you consider that a wonderful thing. Nothing is 100% efficient, not even us. There are two equations for efficiency. They're really the same. They're just written two different ways. So efficiency, and it's really a percent, is equal to the energy out over the energy in times 100. So usually we write it as EO over EI times 100. Okay? That is the same thing as saying, the other way of writing it, work out over work in times 100. So again, WO over WI times 100. Okay? You should never get a value bigger than 100%. Nothing can ever be bigger than 100% efficient, and really nothing will be even 100% efficient. So when you're doing the question, if you don't know which one to put on the top and which one to put on the bottom, well, the smaller one always goes on the top, or else you'll be over 100% efficient, and that will just be wrong. Where does the rest, we say when it's not 100% efficient, we say that energy or work gets lost. It gets lost lots of times to heat, to friction, to another type of energy. It gets converted into another type of energy, and nothing is ever 100% efficient. So your other questions today are going to be with this guy. I would write it, depending on what the question says, I would write it as EO over EI times 100 if they're giving me energies, or I would write it as WO over WI if in the question they're giving me work. Okay, so it's not really, a three-way thing. It's this or this, which are the same thing, because remember, work done is equal to the change in energy. Okay, so efficiency.